Hey makers, welcome back to HUB360 Embedded Sphere, your number one platform for embedded electronics tutorial, affordable components, and smart DIY projects. This is part one of our series on building a smart robot platform. In this first phase, we'll be creating a Bluetooth controlled robot car using an Arduino, an L298 motor driver. With this setup, you can control your robots using simple commands sent from your phone, like forward, stop, left, or right, all wirelessly via Bluetooth. And of course, every component we use in this project is available at hob360.com.ng, Nigeria's trusted source for embedded system components. Let's get started. This is just the beginning, a foundational control system for a robot that can later be upgraded with sensors, automation, or obstacle avoidance. In part 1, we focus on Bluetooth manual control. This robot is powered by two DC motors connected through an L298N motor driver. An HC05 Bluetooth module lets you control the robot using your smartphone via a serial Bluetooth terminal app. The robot responds to 4 basic commands, and these are F for move forward, S for stop, L for turn left, and R for turn right. Simple, wireless, and easy to expand in later parts. The components used: we used one Arduino Uno, one L298N motor driver module, two DC gear motors, one HC06 Bluetooth module, one robot chassis, two-wheel drives, and jumper wires, and a mini breadboard, and also two 18650 batteries, and also a battery holder as well. Get all this at hob360.com.ng, where makers shop smart. Okay, connections: motor driver L298N to Arduino. Connect the enable A pin to D9 on the Arduino. Next, connect the in1 pin of the L298N to the D8 pin on the Arduino. Next, we are connecting the in2 pin of the L298N to the D7 pin on the Arduino. Next, we are connecting the enable B pin on the motor controller to the D3 pin on the Arduino. Next, we are connecting the IN3 pin on the motor driver or controller. Next, we are connecting the in4 pin on the motor driver to the D4 pin on the Arduino. Now we are connecting the motor A output pin of the L298N motor driver to the left motor. Now we are connecting the motor B outputs, the motor B output pin of the L298N motor driver circuit to the right motor, and here's the right motor. Next, we are connecting the 12V VCC pin of the L298N motor driver to the battery supply. So now we connect the GND of the Arduino to the GND of the motor driver. Next, we go to the Bluetooth module, the HC06 Bluetooth module. We connect the TX pin on the Bluetooth module to the D2 pin on the Arduino. Here's the Bluetooth module. We are connecting the TX pin. So this is the TX pin, the third pin on the left. We are connecting it to the D2 pin on the Arduino. Then next, we connect the RX pin on the Bluetooth module to the D6 pin on the Arduino. To do this, we use the voltage divider to avoid damage to the circuit. And let's make a voltage divider. Okay, great. Now I made a voltage divider circuit, so we go on to connect the RX pin on the Bluetooth module to the D6 pin on the Arduino. See the RX pin, second to the last to the left. So we now go on to connect our VCC on the Bluetooth module to the 5 voltage on the Arduino. So this is a VCC, the second to last on the right. Then we connect the ground on the Bluetooth module to ground on our Arduino. Important note, the HC05 RX pin is not 5 voltage tolerant. Use a voltage divider, a 220 ohm resistor and a 440 ohm resistor on the Arduino TX line, just as we did here. Okay, code walkthrough, step by step. Let's now break down the code and explain what's happening in each section. First, library and Bluetooth initialization. So here we include the software serial library, so we can communicate with the HC06 module using pins D2 and D6 on the Arduino. Then we go to the motor driver pin assignment, which is here. So in this place, these are the motor control pins. They enable A and they enable B control motor speed using the PWM. In 1 to in 4 control the motor's direction. Then thirdly, we go to the command buffer setup. The command buffer setup, this is it. So here in the command buffer sector, we use a buffer to store incoming characters from Bluetooth and process full commands. Then we go to the step function, which is here, this place. This is the step function. What we did here is that we configured all motor pins as output, start serial communication with the PC, and begin Bluetooth conversation at 9600 baud rate. Then we go to the movement functions, which is here, this place. This is the movement function. And then in the movement function, it sets both motors to rotate forward at 100 PWM speed. Then next, in this place, we turn off all motor inputs, stopping the robot. And then in this place, see the analog rights. We use one motor. One motor moves forward while the other moves backward briefly, causing a right turn. Then finally, our turn left. We use similar logic for turn left. For left turn, the short delay allows partial rotation, then motor stop. Then we go to the main loop. Alright, in the main loop, this place you are seeing, if Bluetooth sends data, we start reading it character by character. And then when a full command is received, like a new line and carriage return, we terminate the string and reset the index. Next, we match the command and call the appropriate function. Then in the else you see here, this else, in this section, if the input isn't complete, then we keep storing characters in the buffer. That's the input command. If it isn't complete, we keep storing characters in the buffer. Upload the code to your Arduino. Pair your phone with the HC06 Bluetooth module. Open a Bluetooth terminal app and send signal later commands. F, move forward, S for stop, L for turn left, and R for turn right. Watch your robots come to life as you control it wirelessly. And that wraps it up, part 1 of this robot build. You've created a solid base, a Bluetooth controlled 2-wheel drive robot car using Arduino and L298N. From here, we expand this into a fully autonomous robot in upcoming parts. Like this tutorial if it helped, subscribe so you don't miss part 2, where we add obstacle detection. Grab your components now at hob360.com.ng, your maker's hardware HQ. Until next time, keep building, keep learning. This is HUB360 Embedded Sphere, helping you bring your ideas to life.